Thank you, sir. Dr. Nibaran Das is a professor in the Department of Computer Science and Engineering, Jadavpur University, Kolkata. Professor Das is a renowned researcher in the field of deep learning, pattern recognition, microscopic image processing, and optical character recognition. Over 200 articles have been published by him in scholarly journals and conference proceedings. He has written multiple books and working as an associate editor of Sadhana Journal. So now I would like to request Professor Nibaran Das sir to chair this session. Sir.
Thank you, organizer. It is my privilege to be a session chair here. So I introduce Dr. Swarnajyoti Patra, who is an assistant professor in the Department of Computer Science and Engineering, Tezpur University, since 2013. He received his PhD in engineering from Jadavpur University, Kolkata, in the year 2009. During 2009 and 9 to 2012, he was a postdoctoral researcher in Italy, and Dr. Patro act as a referee for different renowned journals in IEEE transaction and geoscience and remote sensing, transactional image processing, pattern recognition letters, and he has published a lots of paper in those journals. His research interests mainly include pattern recognition, evolutionary computation, neural network, and remote sensing image analysis. Today he is going to deliver a very important talk on active learning and its application for remotely sensed image classification. And all of we know that today data is very important, but labeling of data is costly. So active learning be a particular solution for labeling the data. So in his abstract, if you notice, we notice that he used the supervised technique, he can use some kind of data labeling technique, and I think they are to improvise the results. And he will describe those active learning techniques from very basics, so that everybody could understand, as well as he will describe a particular application in area where he could apply, and it would be our privilege that we can get his expertise on this area about how the active learning techniques, as well as its different application in different fields. I welcome Dr. Patra to start his.
Thank you for your nice introduction. So, can I get pointer? Okay. So, good afternoon, everybody. So, I am Dr. Swarnajyoti Patra from Tezpur University. So, today I am going to give a very basic concept of active learning. Although it is active learning, but I think from my talk, the PhD student, initial stage of the PhD student, or those who are doing masters, they can get some good idea about machine learning. So although it is active learning, forget about this term active learning, but some basic knowledge in machine learning, which if you work on data science or pattern recognition or software, whatever, this kind of knowledge may be required. That I try to everywhere. Okay. So, so this is the outline of my presentation. I divided my talk in four parts. First one is I just give brief introduction about the what is supervised learning, unsupervised learning, then semi-supervised learning, and active learning. So most of you are familiar with this stuff, but still I will say something so that I can correlate with this all these four stuff. Then in the next part I will give a discussion of support vector machine. So most of you are familiar with the support vector machine, na? But how it's classified for multi-class program. We know support vector is a binary classifier. For multi-class program, how actually it's work. That I will give in detail. And why I will give support vector machine over that? Because the active learning technique what I am going to discuss, all these techniques are based on the support vector machine classifier. We will explore the properties of the support vector machine to describe different active learning method. That's why I will give some details about the support vector machine in this talk. Next, I will present some active learning model. So in active learning model, actually I work active learning field in 2009 to 2013 when I was doing postdoc in Italy. So we also developed many novel techniques. So before going to our techniques, I will discuss the literature technique, what are the existing. Then I will give one or two techniques that we developed. Finally, I will show you some result on remote sensing based processing, but not that. This technique you can apply anywhere in the machine learning field. So everywhere it will be applicable. Okay. So these are the outline of my talk. So supervised and unsupervised learning, all of you are familiar. So thing is supervised learning means it needs some level data. Some level data. So that we can, with help of this level data, we can train a model. We call it classifier. You can train a classifier. After that, the unlevel sensor will be full feed, it will classify. So supervised learning means we need some level sensor. And unsupervised, so this is an example of supervised example. You can see we just use this rare box, they are the level sample. With this level sample, we train our model. After completion of the training, we feed this unlevel sample and our classifier will classify it. And in unsupervised case, we don't need any level sample. We don't require any level samples. We can design some criteria. We can design some similarity measure. Based on the similarity measure, our model will look similar object. So there is no need for level samples. So what is the advantage of supervised technique? Supervised technique, if we have adequate training samples, if we have sufficient number of training samples, then our classifier will perform good, satisfactory result in classifiability. Now that we know. So this is the advantage. We can get a desired result. But at the same time, what are the limitations? There are many limitations. In this level sample, the collection of this level sample is very costly. Either you go for expert or you ask for field sample. So these are the costly things. So usually level samples are not available. And if level samples are available also, they are not adequate for training. Means suppose you collect some, but they will not represent the distribution of the whole classes. That time also your class level don't work. You have to have the samples that can follow the distribution of the different classes. And using that samples you can classify. Otherwise, this will not work. And often when we collect the level samples, there are a lot of redundant samples will be collected. So if we train with the redundant samples, then what happens? Unnecessarily, the classifier will take some time. You don't need to feed so many redundant samples. No? So these are the limitations of supervised learning. So the most important limitation is the level collection of level samples is time consuming and costly. Answer the unsupervised technique advantage is it's remove all these drawbacks. You don't require any level, you just feed the unlevel samples. That you design proper similarity data, based on the similarity data, it will group them similar objects. But the thing is, the advantage is usually unsupervised technique when you use, we are not getting so much good result because we don't have any training set, nothing, just based on the similarity data. And data distribution of different tests, their distribution is different. So one single similarity measure if you define, that will not going to work for other data set. No, different data set have different type of distribution. They are very much complicated. So we can't be able to define a single criteria which will work for all kinds of data sets. So usually supervised technique provide not good result as the when you compare with the supervised technique. If we can provide the sufficient levels, then we will give good result. Okay, so this is the unsupervised supervised technique. Maybe this 2 minutes, 3 minutes, but I explain. Everybody know this thing. Okay. Now, so there will be some trade-off between these two. Now, one is there is level simple, lot of level simple, another is there is no level simple. In the between, there are some technique people develop. Researcher develop some technique. Also, these are the technique learning with limited levels. It means small number levels simple, but we are not compromising with the classifier performance. Classifier will give the good result, satisfactory result, but using small number of levels. So, what are the techniques exist in the literature that can do this kind of thing? We know semi-supervised technique. Semi-supervised technique can do this. So, what is the semi-supervised technique? Maybe this diagram maybe tells something about semi-supervised technique. So, here maybe initially we have small number of levels, very small number of levels initially that we use for training purpose, and we train with this small number of level sample to the classifier. Once classifier trained, there will be a criteria. We will check whether the classification performance is successful or not. If it is not, we can cancel query function. This query function means this is nothing but it will explore the unlabeled sample and try to find out some samples which are most uncertain. And if we include them into the training set, if we put their level of criteria, include them, maybe classification performance will be improved. But this query function we have to design such a way so that it can select the proportion from the unlabeled samples. So for semi-supervised technique, you can see there is no human expertise that involved over here. So we have to select the samples which are more certain. Certain means the sample which have probability of belonging any of the one class is high. Suppose there are 4 class, maybe the sample we are selecting, maybe class number 1 is probability of belonging is very high. That means it's certain. It is more probable of belonging in a specific class. So that we can automatically label, okay, because this is a sample which have high probability of belonging in a specific class, so we automatically assign that, okay, your label is this one, and add them. So semi-supervised technique, the thing is we have to design a query function that can select a sample which are more uncertain, and not only uncertain, if we automatically label this sample, this labeling error will be less. The labeling error will be less. So proper kind of certain sample you have to select for labeling purpose. And here labeling is performed without any supervision. Automatically it will be labeled. So after that, assign the label, we can put them in the training set. Again we iterate this. So later we can explore the unlabeled sample and we can try to improve the classification. But the drawback of semi-supervised technique is after certain extent it will not improve the result. Okay. So what I explained, I think this is it possible to scroll down this one? No? That's right. Thank you. And explaining everybody else the result. Thank you. So this is actually I was discussing this semi-supervised. There is no supervisor. There is no supervisor. Just this query function select some most certain sample. Most certain sample it will select. So there is no supervisor. Certain sample automatically assign the level based on the certainty value, and then it checks. So it will improve the classification performance if we properly select the sample. But after certain extent, it will not able to improve the result. So there is another kind of techniques are there that can also handle it. That can also classify your classification task using less number of levels. So it is called active learning. So the difference in the previous slide and this slide, you see the difference is that one is supervisor over there. Here supervisor is missing. Here supervisor is missing. So in supervisor learning there is no supervisor. So if there is no supervisor, then this query function criteria will be changed because here human expert is there. So you can select instead of certain sample, you can select most uncertain sample. Means you don't know. Every class name is probability of belonging is equal. So which class it belongs, we don't know. So we can ask the supervisor, tell me what is the particular level. So he can go for round survey, or he may be an expert in a doctor. So he can see the pixel and tell you, okay, this is belongs to this class. After getting its level, we put it in the training set. And after that training set, again. So that way we can only include the informative sample. So after few iterations, we can our class will be confirmed and it will give the same result as the traditional supervised technique gives, using huge number of training samples. So that way also we can solve this problem. So what I explained semi-supervised learning and active learning, I can try to explain it with this figure. So you can see when semi-supervised learning technique we use. Suppose these are the two classes. This is class 1, this square box, and this is suppose class 2. There are two classes. So initially we have only small numbers. These are the two samples from class 1 and class 2 samples we use for training. So when we take only small number of samples, they does not follow the distribution of the class at all. That obviously the classifier that this decision boundary will be passed through completely wrong region. Like initial stage, the decision boundary will pass through completely wrong region. Now in semi-supervised learning, what we try to do? We try to select the certain sample. So here certain sample is what? If this is the decision item then, so all the samples which are far from this decision item then, they are more probable to belong to class 1. And these are the samples, they are more probable to belong to class 2. So if this is also certain, but if we select this one, okay, so these are all certain samples. Suppose if we select this is certain sample, what will be its level? If you automatically provide the level of it is positive region, so its level should be class 1, but it is actually belongs in class 2. So this is the challenge. You have to select the appropriate certain sample, and which is not a simple task. So this is the semi-supervised technique. In semi-supervised technique, try to select the appropriate certain sample, which is very difficult to select. But in active learning, on the other hand, we try to select the most uncertain sample, meaning the sample which are near to this decision boundary. So these are all uncertain samples. We don't know. This sample may be same probability of belonging to this class and also same probability of belonging to this class. More or less equal probability. That time we can select it and ask the expert, give the level. He can give it. So we just assign this level. In next iteration, maybe classification, this classification model will be changed completely, just including one sample. So just few samples we need to add it with the help of some human expert, and we can go on. So this is the basic thing. So I discussed in this first part I covered. I discussed supervised, unsupervised, semi-supervised, and active learning. What are these relations there? And semi-supervised things, of course, it has some advantage. Active learning has some disadvantage because you need a supervisor. But we need to be less than this. Okay? So now the second part is, before discuss the active learning technique, I will going to discuss few literature method and also some proposed method. But before going to this, I would like to say something about the SVM, support vector machine classifier. Because whatever the nowadays, up to until now, whatever the active learning technique people are developed, all are based on this exploiting the SVM classifier. Because this is a robust classifier and it is very much suitable to design active learning techniques. So that's why I just try to say something about active support vector machine classifier. So support vector machine classifier, we all heard this. What is the support vector classifier? This is a binary classifier. So here you can see these are the two classes. This blue samples, they are belongs to one class, and this red sample they are belongs to another class. And these are all training samples, means they have level. Now based on this level sample, support vector machine try to classify them. So how it's classified? How it's classified actually? support vector machine, based on this training sample, it tried to find out margin. It tried to find out a margin so that this class sample of belongs to this first class and this second class, they can be completely separated. So there are many margins if you can, if the techniques can find out, the ability to find out. Like suppose if we consider this training set, this training sample and this training sample, it can be get a margin like this one, small margin there. If we consider this one and this one, maybe this one and this one, there are thousands of margin, different margins you can there. Out of this thousand of margin, it use the optimization technique that will maximize this margin. The margin that will maximize this hyperplane is considered as a actual hyperplane to classify them. So here in this example, this is the hyperplane hyperplane generated to define the margin, and this hyperplane generate the maximum margin. That's why subplane is also called maximum margin classifier. We find out the maximum margin between the training set. There is no only level set there. All are level set. We find out many margins, find out many decision hyperplane, and select the one that has the highest margin by optimizing this criteria. Okay, this is the means. I just give an abstract idea. This is where subplane calculation can. Now, this decision hyperplane, how can we define? We can define it in this. There are this is the sub. The margin which are defined using the training sample. To define this margin, we need only these 4 training samples. They are called support vector. These are the positive support vector, these 2, and these 2 are negative support vector. So this decision hyperplane is defined with these functions. This is alpha is the Lagrange multiplier of first support vector. Then yi is either plus 1 or minus 1, means the level of the samples. So if we talk about, if you consider this is a positive plus, this is negative plus, so its level will be plus 1, its level will be minus 1. So alpha 1 is the Lagrange multiplier of this sample, and y1 is the plus 1. Then this is cardinal function. This cardinal function will be all are about cardinal tree. Means the example what I am saying here, they are completely linearly separable. But in practical case, data are not linearly separable. So support vectors, how can they then define this margin? They just project the data into higher dimensional free surface, kernel space. Now in kernel space, what is the dimension? Infinite. So how can you compute the distance between two samples in a infinite dimension? It is not possible. So there we apply the kernel. Means this is a kernel function, then follow some functions of that. They can compute the distance of two patterns in higher dimensional feature space. So that's why we are using the kernel space. Means the data are projected into higher dimensional feature space in kernel functions. After that, this kernel function will be used to compute the distance, approximate distance. So this is the function. So if any sample, now this x is the any samples, maybe level sample, unlevel sample, whatever. So if we put these samples over here in these functions, it will give this is the distance minus 1. So the perpendicular from this point to this one will be maybe minus 1.5. So the sample which belongs to on this hyperplane, their distance in the function, this distance function will be 0. The sample which belongs in this negative margin, their distance will be minus 1. So these samples, if we put over here, its distance would be the distance minus 1. Means the perpendicular distance from this one to this one will be minus 1. So all the support vector they have either plus 1 distance or minus 1 distance. Okay. Now beyond this margin, this sample has more than 1 distance, and beyond this margin they have less than minus 1 distance. For example, suppose. Okay. So now suppose this is a unlevel sample counts. So our classifier with the help of this training set, it classify, and this is the distance hyperplane generate. Now we want to classify an unlevel sample. So this is the unlevel sample we want to classify. So how support is classified? We just put this value as x, consider x. So this will give a result of positive value. How much? Maybe 0.5. Now this is the here all are 0, so this will be 0.5 distance. The perpendicular from this one to this. 0.5. So 0.5 means it is positive value, so it will belongs to class 1. So it will assign class 1. So again, next, suppose another sample comes over here. So it will give the value maybe minus 0.7. So it will assign in second class, this class, negative class. Similarly, again another value, so this may be 1.5. So it will be positive class. Then another value may be minus 1.10, minus 2. So it will be in negative class. So that way, support vector machine can classify. So what I discussed all are binary vector. Now there are two classes we can classify. Now if I ask, is that multiple class? How support vector classify? If there are 3 class, 4 class, how it's classified? So up to this one, maybe most of you are familiar. Okay, this is the binary subvector machine. They classify like that, right? So we know. So when multiple class comes, how subvector machine classify? They use many different architecture of binary networks. The most widely and popularly used two architecture are one against all and one against all. These are the very most popular of those who are working on subvector machine. They are familiar with these two terms. Okay. So what are these? So first is one against all subvector machine. How it's classified? Multiple class. Multiple class, like there are 3 class. Now you can see there are 3 class. Class 1, class 2, class 3. We want to classify it using subvector machine. So let's assume these are the level symbols. All are level symbols. There is no unlevel symbol. First we will train. First we will train is the level symbols. So one against all means it consider one class as a equality class. The rest all negative class. So first this class 1 will be positive class. Other class are negative class. So it consider like this one. So this one is a positive and the rest 2 class will be negative. And so this become a binary. Now this is become a binary class problem. So it's defined this hyperplane F1. The same concept as you classify, it define the F1 this hyperplane. Next, it consider the second class as a positive class. Rest are negative class. So again it define this hyperplane. This one. Third, it consider the third class as the positive one. Third class is positive and rest are negative. So 3 this hyperplane is defined. So all are binary as well. So we know how to solve this problem. So now we can construct the binary distant function f1, f2, and f3. Now how can you classify? Suppose an unlevel sample comes. This is an unlevel sample comes. We want to classify it. Which class it belongs? How can you classify it? So in one against all, so you can see, we can compute the distance from the first distant boundary, first distant hyperplane. So distant hyperplane will be positive, some positive value. Next, we can compute the distance from the second distant hyperplane. Next, we can compute the distance from the third distant hyperplane. How can you compute this distance? This is nothing but if you put this unlevel pattern to these functions, it will compute the distance. So among these 3 distances, which one is the highest distance, highest positive distance? This one is the highest positive distance. These are the negative one. So that means the class belongs to class 1. This unlevel sample belongs to class 1. This is the formula I use here. So this unlevel sample will be assigned to class 1. So this is the one against all architecture. Most of you heard about this, but actually how it works, maybe you are not aware. So this is the way it assign it perform the classification task. Now 1 against 1. There is another architecture. This is also very popular. Many people are using this classifier. 1 against 1 classifier solving multiple class problem. So here NC2 number of combination of binary SVM will be generated. NC2. So if the number of classes are L, then NC2. So I have 3 classes, 3C2, so 6 binary SVM are generated. Okay. You can see first we can consider this is a class 1 and class 2. We are considering only these 2 classes. So 1 binary SVM will be generated. We are considering 1 and 3, another binary SVM will be generated. 2 and 1, this one. 2 and 3, this one. 3 and 1, this one, and 3 and 2, this one. 6 NC2 binary SVM will generate. After generating this, so for an unlevel sample, how can you classify? We just compute the distance. And then we find out the highest positive distance. Highest positive distance here you can see, this is the highest positive distance. This one. This is negative one. This is also negative. This one is negative. This one is smaller than this one. So this is the highest positive distance. So the class, so this unlevel sample belongs to class 1. How can I sign this? So this is a simple way SVM classifier works. Okay? And this is a formula. I don't think I have to explain this formula because everything I explain in picture. Nah? Okay, so second part is also over. So only two. Huh? You need to wait for only two part. But this will take some time. I think maybe half an hour to explain these things. So as we have classified at least few little bit idea you have to, now you have.
So I have one question, sir. You can go to the previous slides. So one versus one, you are always emphasis on positive one, right? Positive sample, but if you have a multiple class, so positive sample might be different, right? For example, it might be for plus. That is it might be misclassified, right? So on that case, how do you resolve the issue? So positive class, so in general it would be positive class for a particular class, right? It should be categorized.
Every class will be positive and negative.
Negative, right? But the thing is that here, that's why if you are just in the first one, first figure, it is a positive as well as if suppose you
positive for this one also.
then just how would you think that it would be on the for the positive? It's just for the confidence.
Yeah, it is more probable, no? Belongs to this class.
Just based on the probability.
Based on probability. This is the I am not doing this. This is a literature technique I just explained. This is the more probable belongs to class one. Okay, just confident. Now active learning. Again, you have to memorize what I told. What is active learning? Active learning means you have to select the fundamental task of active learning is to select the most uncertain sample from the unlabeled. There are huge number of unlabeled samples are there. You have to find out which one is most uncertain, and just ask supervisor, give me the level. If give you level, you just put it into the training set and again you put it. So this is the fundamental task is to select the appropriate level sample, appropriate unlabeled sample to be labeled. No? So in literature there are two kinds of active learning techniques are there. One is single mode and another one is base mode. The name tells everything. No? Single mode means each iteration we are selecting only one level sample, one sample for leveling. From the huge number of maybe 1 crore, maybe 2 crore unlabeled sample are there. From that sample pool, we are just selecting only one and label it and add it to the classifier training set and retrain it. This is called single mode. So obviously it has some drawback because how many times will you train the classifier? Every time one sample will select and train, another sample will be selected and train. So it will take time to learn. So people also develop base mode active. Base mode active learning means multiple samples at a time you can select and label them and add them. Okay. So first I will discuss the single mode active learning. Then I will go for multiple mode. These are the techniques I am discussing. These are existing in the literature. Okay. So single mode means you need to select only one sample. So if you need to select only one sample, we can only try to find out which sample is the most uncertain. So in the literature, to find out an uncertain sample, these are the criteria I use. Margin sampling, then multi-class level uncertainty, then entropic query-wise dating. These are the three fundamental criteria people are proposed to find out the most uncertain samples. There are many other criteria also there, but most of the literature you can find out people are using these three, any of the one. So, what is margin sampling? Margin sampling idea is, I think you already got it when I discussed the SVM classifier. Margin sampling means we are using one against all SVM classifier. So, suppose, for example, this is one against all classifier I already explained. So, I have three class problem. I convert it to one against all three binary class. Now this yellow circle are the unlabeled sample. These are the labeled sample, and this yellow circle are the unlabeled sample. Now for this boundary one, suppose I want to compute the uncertainty value of this unlabeled samples. This yellow one. So how can you compute its uncertainty level? I can compute its distance from this one to this hyperplane. I can compute its distance from second hyperplane and third hyperplane. And then I assign the uncertainty value of this one with the lowest one. Because in this case, if I label it and if I assign its level, maybe this distance hyperplane will be completely changed. So here margin sampling is try to find out the sample which are on the distal hyperplane. They will be most uncertain. So in this example, which one will be most uncertain? They will tell you which one will be the most uncertain. I can tell you this. This is the most uncertain sample. You can see this one. Here distance of this one is very small, but here almost zero. So that means this sample has high means equal probability to belong to this class and also this class. So if we label it, our classifier will be changed, completely changed. So this is the uncertainty that is called marginal sampling uncertainty. It just select the sample which are closest to the distal. Okay, very simple idea. So this CX is what? This is a classification confidence. Means each unlabeled sample we are taking and compute its distance. Which one is the minimum distance that we put here as a classification confidence. So this sample may be a classification of this one, and this sample is classified almost zero. So each unlabeled sample we compute the classification confidence. After that, the sample which is lowest classification confidence means the sample which is on the hyperplane, they will be selected for level. So after selecting it, we can level and again train. So this is one criteria, very popular. People are using this one. Now the second one is, this is the most familiar and most powerful criteria. It also exploits the assumed classifier to define. It try to find out the thing like different way. Suppose this is my hyperplane. Now for class of 1 against assumed classifier, suppose this is the unlabeled sample. So the distance is suppose 1 here. And another hyperplane, its distance also 1. That means what? The sample, same sample, its probability of belonging in one class is 1 and another class also the same. So the difference is 0. That means this sample is equally probable to belong to both classes. So maybe this is uncertain. This is the most uncertain. And so here we did these things. You can see first for this sample. So this is an unlabeled sample. This is the unlabeled sample. Same unlabeled sample. I draw in 3 times because there are 3 binary classifiers there. So I compute the distance. This is positive. This is negative distance. This is negative. This is again negative. So highest distance is this one. Then the second highest distance is this one. So I compute the difference. What is the difference? That will be its classification confidence. So here the classification confidence may be more. But so I compute the first one means highest distance. Compute the second highest distance and their subtraction. The subtraction is 0. That means first class the highest distance from this pattern. First class and second class, it is almost equally probable. That means this is the most uncertain. So you can see in this example, which one will be most uncertain? This sample. You can see here its distance is positive, maybe 0.1. Here also 0.1. And this is the negative one, so it is the lowest one. We will not consider. We just consider these two. 0.1 here and also 0.1. Both are plus. So the difference will be 0. The classification confidence is 0. That means this is the most uncertain. And practically this criteria work better than the marginal sampling. Okay, so this is called the multi-level uncertainty criteria. Okay, MCLE. Then another interesting uncertainty level you can. So these are the things means those who are in the initial stage of PhD or master's level. These are really helpful. You can try to analyze these kind of things because people are now all are bringing in what deep learning without knowing anything, without what is going on, what is go out, what is coming, nothing. Try to understand how the things are working. So here you can see another uncertainty criteria. How we can select uncertainty sample. This is the called entropy query by bagging. Bagging means we construct bag of classifier. Means multiple classifier. So how can we construct? Suppose this is the same problem, 3 plus problem. So I just add some bootstrap sample. Bootstrap sample means I just randomly select 10% of this training set. So this is suppose 100% my training set. Now I select only 10% and I construct. This is the training set. So randomly I am selecting 4 different set I generate. From whole training set, I randomly select and generate 4 different training sets. Suppose this is from this training set, 10% I randomly select here, 10% I randomly select here, 10% and 10%. So 4 different training set I generate. After that, with this training set, I train my SVM classifier. Suppose one I install, I train it. So when I train this one, I found some dictionary problem. When I train with this training set, I found another dictionary problem because they are not exactly same training set, so dictionary problem will also change. For this one, again another 3 set of dictionary and another 3 dictionary set of hydrogen. Now, suppose one unlabeled sample comes. This is the same unlabeled sample in the 4 classes it comes. So these are called the bag of classifier because they have 4 classifiers there. We are using SVM classifier, but since the training set is different, this classifier will be different. They are drawing the different dictionary. Now suppose this is the unlabeled sample comes. So for this classifier, it will classify some maybe class 1 or class 2, class 3 depending on the SVM property. For this training, for this classifier, it will again classify maybe 1 or 2, for this one, this one. So 4 different decision we can get. Maybe this first case, this one will be assigned to class 1. Second case, this one will be again assigned to class 1. But this third case maybe it will be assigned to class 2. Fourth case will be assigned to class 4. So you can see that I am drawing over here. I can draw an histogram. So this same sample, this is only single unlabeled sample. Where this classifier classify it as a class 1. This classifier also classify it class 1. But this classifier classify it as class 2. And this classifier class 3. Okay. So now I take another sample, another unlabeled sample. This one. This one, when I take, maybe all these 4 classify it in class 2. So now can you tell me which one will be more uncertain? Which one will be more uncertain? One sample, this one, yellow one. All these 4 classifiers agree it belongs to class 3. Class 2, it belongs to class 3. But in the first case, this violet color one, there are 2 classifiers say it will belongs to class 1. And other 2 classifiers they say no, it belongs to class 2. Other one says it belongs to class 3. So this one will be more uncertain. Now this will be more uncertain. But how can we mathematically find out this one? It's more uncertain. If we try to find out the mathematical value, this is more uncertain. We can just compute entropy. Entropy of this one will be 0. Means all classifiers agree it will be belongs to class 1. But when entropy is uniform distribution, that means all classifiers disagree. Everyone is disagreeing. No, I'm saying oh, he belongs to this one. Another one says no, he belongs to this one. Another one says no, he belongs to this one. So everyone is disagreeing. Means this is the most uncertain one. No, this is the most uncertain one. So we can just compute entropy. Here entropy will be 0.45, 0. That means this is a certain sample, but this is compared to this one, this is more uncertain. So we just compute all the unlabeled sample. We just compute their entropy, and the sample which have highest entropy, that will be the more uncertain. Okay. So these are the 3 people use to select the most uncertain sample. Okay. So single mode active learning, people just doing these things only. Either they use marginal sampling or MCQ criteria or entropy criteria again to select the uncertain one. After selecting the uncertain one, they label it and classify it. Okay. Now base mode active learning. So base mode active learning not so simple. Means why? Because base mode active learning in a single iteration we are selecting a multiple sample. So when you can see, suppose these are the 3 class, same class, but these are the unlabeled samples. This yellow circle are the unlabeled samples. All are unlabeled samples. Now just apply uncertainty criteria. If we select multiple samples, what happens? These are the samples will be selected because they are near decision boundary. So if we apply marginal sampling criteria, then these are the samples, maybe m number of samples we are trying to select. So this sample will be selected. Now look at this. So you can see these 3 samples are selected, but they are redundant. Instead of 3, we can take 1 only from this one. Instead of this 3, we can take only 1 because they are providing same information. So when you talk about base mode active learning, only applying uncertainty criteria will not solve our problem. We have to apply diversity criteria again. So first we will apply uncertainty criteria to select some informative sample, to select some uncertain sample. After selecting this uncertain sample, we can apply a diversity criteria. so that we can select diverse sample. Here maybe we can say, okay, among these three we want to select only one. So we can cluster them, and from each cluster we will take one sample. So these are the diverse, they have no redundancy, and now we can label it and edit it. So based on active learning, when we talk about, we are talking about informative samples, not uncertain samples. Informative samples means it is uncertain as well as it is diverse, means there is no redundancy. Okay, so we try to select the informative sample. These are the informative sample we can select. So this is the basic, the fundamental idea of base mode active learning technique. So in base mode active learning again, so for diversity criteria, you are all of you are familiar with K-means clustering. So there are many other diversity criteria familiar with angle-based diversity, then cluster closest support vector-based diversity, then cluster-based diversity you can apply to select the diverse sample. Okay, so angle-based diversity is cos theta. This is a very famous similarity measure criteria. So cos 3 means cos 0 means 1, cos 90 degree means 0, cos 180 means minus 1, means when theta is increased, value will decrease. So cos theta is actually, we can compute the distance, not distance, similarity between two vectors. Suppose this is A is a vector, B is a vector. If we compute the cos theta, this cos theta tell us the similarity between these two vectors. If they are same vector, then angle will be 0. That means the value will be high. If they are dissimilar vector, angle will be high, means value will be low, minus. So that similarity measure we can use to select diverse samples. We can select. So sometimes in active learning measure, people project them because they all use SW classifier, so they project them into the kernel space. So kernel space, this cos theta will be used like this for kernel function they use to compute the cos theta value and compute the dissimilarity value. So cos theta you can apply to find out the diverse sample. Okay. Then another is closest support vector. This is also very interesting. You know what is the, so if this is the support vector, here which one is the support vector? Support vector are this one, and this one. They are positive support vector, and these three are the negative support vector. Now we want to try to select the diverse sample. How can we do it? First we select, apply uncertainty criteria. So we select these are the near to the, all these sample are near to this nitrogen, so they are uncertain. All these are uncertain. These are all uncertain. Now we have to select the diverse one. So how can we select diverse one? We can select it. First, this sample we will select. Why this sample we will select? Because this sample is closest to this support vector. Next, we will select this one because this one is closest to this support vector. Next, we will select this one because this sample is closest to this support vector. And next, we will select this one because this is closest to this one. And next, we will select this one. This is closest to this support vector. So only these 5 samples. There are 5 support vectors, so only 5 samples will be selected. It will be diverse. Just very cheap criteria you can apply and you can select the diverse sample. No K-means, no nothing. You just train your SVM and you can select it. Nothing costs the no need to compute anything. Okay, a nice way you can do it. Okay, so this is another sample. Now this one you are familiar. I think I don't need to explain this one. Now we can select uncertain sample, same way you can select the uncertain, then you can apply the K-means cluster. Maybe suppose you want to select 4 informative samples, so K is equal to 4. We cluster them, and from each cluster, we select the sample which is closest to this one. So we just cluster it, and then select one sample from each cluster to have diversity. So that way you can also do it. So these are the diversity characteristics. So now combining this, okay, still these are the sample you select from each cluster, and diversity selected. So these are the literature technique what I talk about. So in the literature, whatever the criteria I explain, these are published in many papers. Uncertainty single mode active learning, these are the Martin sampling, MCADU, their N25 making their use. And for diversity, when we apply diversity with this uncertainty plus the angle based or support vector based or clustering based, there are many techniques about. So almost 10 paper I explained. Okay, I explained so many things. And it is simple thing.
But we
huh?
do not have time.
Huh?
We do not have time.
Oh, no, how like that? How?
No. You can continue. I understand. You want to explain 10 papers, but
No. It's a very simple thing, na? Is there any difficult things in common? Nothing. Machine learning is so nice thing. You don't need to go very high, become, you don't need to become very quite completely mathematician. Simple mathematics, if you understand, you can understand many things. These are the things people are heavily used. Everywhere. Clustering you are using, na? Huh? Uncertainty data, entropy, this, then this. MCA doing support machine are there, so we can how can we compute the classification confidence. They are basic mathematics you need to understand. Huh? So far whatever I discussed, all are very simple things. Now, so these are the what I discussed, all are exist in the literature, I just explained them. Now I work 4 years in the Telco. My supervisor is also a big machine learning researcher maybe. So what I do I work. So that time I also developed some active learning techniques. Many 3-4 novel techniques I developed. Out of this 2 I want to explain here. Very briefly I will explain here. This is our method I propose. We propose. Based on support. So the marginal sampling criteria I told. Marginal sampling criteria what they try to do. So suppose this is the support. These are the training set. If we apply one eigenstone, we will get 3 distant hyperplane. This is the distant hyperplane we will obtain. Now the sample which are close to this hyperplane, we are selecting them as a uncertain sample. So these are the distant hyperplane F1, F2, F3, and the sample which are close to this hyperplane that we are selecting the uncertain. Instead of that, we are applying a cluster assumption criteria. Means, you know what is cluster assumption criteria? Cluster assumption means the distant hyperplane should pass through the low density region. If there are 2 classes there, so distant hyperplane will always pass through the low density region. Now, this assumption we apply. Means instead of taking this distant hyperplane, we are all these are the unlevel sample. We first we train the SVM classifier with this training sample. Then we pass all these unlevel sample through the SVM and compute the distance from this distant hyperplane. So their outputs, this was the output, and we plot a histogram. If you look at this histogram, you can see that is some 0, then negative side, positive side, some sample will have distance 1, maybe 10 sample have distance 1. So I just draw this 10 sample have distance 1, then minus, then 0 sample they have maybe 2 sample have 0.1 distance. So I complete. Now if you look at this very region means this is the low density region. They are less sample, this is the low density. So how can you find out this low density region automatically? Can you tell me? How can you find out this low density region automatically? Just like a histogram threshold, na very cheap technique again. Lot of famous chemical histogram threshold, na Tezpur threshold, Prof threshold, GitLab threshold, many cheap techniques are there. So you can just apply, and you can find out automatically. You can detect this is the threshold. So instead of considering this hyperplane, I consider this is 0 fx. This is the hyperplane is equation equal to 0. Instead of this 0, I can take this value, this threshold value is the hyperplane. And the sample which are closest to this distant hyperplane, which has passed through this low density region, means this region, I select them as the uncertain. That means my technique will be more quickly converged because initially you have very small number of samples, so your distant hyperplane pass through complete wrong region. Maybe the lower density region will be somewhere else, but I try to find out this lower density region at the first iteration. So I can select much better uncertain sample. So this is the key idea here. I just instead of using SVM distant hyperplane, I find out the threshold value. That I will use is the distant hyperplane. The idea is the distant hyperplane should pass through the low density region. So the uncertain sample should belong to the near to the low density region. That is the idea. Okay. So then that I did many things. So this is another technique we developed. Very nice interesting technique. Means some self-learning teacher we don't know many of you heard maybe many people also don't heard this. Self-learning teacher we don't know. So I tried to exploit self-learning teacher to find out uncertain sample. So this is a sum network. How much time?
so 10 minutes. 10 minutes.
10 minutes. I think it's I think maybe more than before that. So this is a sum. It is a fully connected neural network. This is the output neuron. These are the input neuron. We can feed the data through this, means feed the feature through this input neuron, and it will self-learn. It will automatically train such a way so that it can follow the distribution of the pattern. Suppose these are my input samples. Initially, my weight with this weight are then now we set, so these are like this. When the training is complete, the weight become like this. That will be similar kind of past techniques. Means the sample, this kind of sample are made over here. This kind of sample made over here. This kind of sample made over here. Means the distribution of the data is preserved over here. So this is the self-learning network. So I just use this one in active technique. So this is synthetic data I use. So I have four classes. This is one class. This is another class. Generate. Then I train this data to the self-learning data. These are the neuron, output neuron. Okay. When it trains, this neuron will map the sample which belongs to this class. This neuron map this class, this neuron this class. And this training is unsupervised, completely unsupervised. There is no leveling considered there. Unsupervised. So after training, we know the sample which map to this neuron, all these samples are mapped to this neuron. So instead of selecting, so we can easily apply the diversity criteria by selecting only one sample from each neuron. So if we select one sample from each neuron, all the other samples, they are all mapped over here. So we will not select them. One sample from here, one sample from here. So they are diverse. So we can easily incorporate diversity criteria. Class perception criteria also you can easily incorporate. You can see these are the low density region. So the neuron over here, its neighbor neuron has higher distance from this neuron. So if you compute the neighbor neuron distance from this one, it is high. But if you compute the neighbor neuron from this one, it is lower. Okay. So the neighbor distance, average neighbor distance is high, means they are more probable to belong to low density region. So they will be more uncertain. The samples which are mapped to there, they are more uncertain. So I can apply cluster assumption criteria very easily over here. I can apply diversity criteria over here. So these two criteria I can apply and I generate my algorithm. So first I compute this neighbor neuron distance, average neighbor neuron distance. Then I compute the MCLU criteria which I explained already. After computing this, I select the sample, M sample I will select. Those are mapped into different neuron, not a single neuron. That will allow me to select diversion. After that, I can select a sample based on this neuron. The sample, the neuron which has higher neighbor neuron distance. That sample I will select. And then I will generate it. And okay. So this is the technique. I discussed many techniques, maybe 10 plus 12 techniques I discussed. So these are the two techniques we developed, and now I just show you some result. This is remote sensing image I started, but the technique what I explained that it can apply everywhere. So these are the one multispectral image and the hyperspectral image I use. So these are the different techniques. These first two techniques are odd, and these are the literature method. You can see this multispectral data. This SOM SGAM means the last I discussed. It provides outstanding data. Means it beats that time when we published it, I think 2013 or something. That time no technique means or developed. It beat completely with other techniques because we apply this SOM to select the cluster assumption criteria that work over here. But the same technique when we use here in the hyperspectral data, it gives better result, but not so much. Why? Because hyperspectral data is high dimensional data. Na? Cluster assumption property will not work there so much. If you have low data, low dimensional data, its cluster assumption property will work very fine. But when you have dimension is high, that time you can't apply cluster assumption data. That's why it provides good result, even better result, but not outperform from the other. So these are the things. Conclusion. I need to conclude. So these are the techniques I discussed, and the very basic technique. I think I say something about active learning, self-supervised learning. Then SVM, especially I think it will be very much helpful those who understand the techniques, how SBM which work for multi-class problem. How SBM work for multi-class problem? Because you will not get this kind of thing until you write the code, until you implement. Nowadays you have Python, you have MATLAB, they are provided. You are using online install, but you don't know how actually technically they are doing the things. So I think you may be benefited what I discussed over there. Then active learning very simple thing. More means those who try to work on this, maybe this is a good beginning. No? So thank you for
Thank you, Dr.
patience to listen me.
Okay, thank you, Dr. Patra, giving a very nice introduction about the active learning and its different perspective, as well as introduced the support vector machine from the very basics. I think all of you have enjoyed his talk. So if you have any question, please ask him.
Heterogeneous means you are unbalanced solution. Which no. That I just give a to present it, but it is completely heterogeneous. They are overlapping, but when you project them in high dimensional space, kernel functions are using, so they will be definitely linearly separable. If they are sometimes they are not traceable, there is a parameter C. C is parameter that used to classify this linearly separable purpose. It is work on heterogeneous, and obviously this data, these two data, they are completely heterogeneous. There are, you can see there are 13 classes of there. Some class have only 100 samples, and some class have 40,000 samples. So completely unbalanced samples are there, and they are completely overlapping from each other. But when you use SVM classifier, it projects higher dimensional space. So the samples which are not linearly separable in the original feature space, they will be separable, and this sample will be generated. It will work. So these two data sets are complete. I don't put a picture. Otherwise, you can see they are completely overlapping each other. They are completely overlapping and heterogeneous.
Any question?
Anything?
Any question in online? Any question in online?
Otherwise, when you can listen my online presentation, this presentation, so if you are interested in machine learning.
Okay. Okay. Thank you, Dr. Patra, for giving a nice talk.
Thank you, sir, for your valuable words. Now I request our chairman, sir, Dr. Nibaran Das, sir, to felicitate our speaker, Dr. Swarnajyoti Patra, sir. And now I request Dr. Pankaj Sarkar, sir, to felicitate our session chair, Dr. Nibaran Das, sir. Thank you, sir. Now, let's resume towards our technical session 2. I would like to invite Professor S.C. Arya, sir, and Dr. Swarnajyoti Patra, sir, on the stage as the chairpersons of this technical session.